Alright, welcome back guys for part 2. Alright, so we're going to look at some examples now. Let's see. Oh yeah, notice this guys, it says when considering these transformations, we're going to work our way from the inside out. Okay, so similar to the order of operations. And we're going to go in this order when we're accounting for these transformations. Okay, so this will become clearer here in a minute. These actually start out with just one transformation apiece, and then we'll see some examples in which there are more than one transformation. So example 1 here, it says describe how the graph of y equals x plus 3. Now notice that's in parentheses and then it's squared. Can be obtained from one of the basic graphs, and then graph the function. Okay. So the first thing we need to do is figure out what is our basic function. And you will have to do this in your homework. Okay. So the basic function, guys, look at the nature of this function. Because it has an exponent of 2, it is a quadratic. And so therefore our basic function is y equals x squared. Okay. You can always look back up here in the list. Okay. It's this, well, they call it a squaring function. But anyway, so the transformed function is y equals x plus 3 squared. Okay. Well, we know how the graph of y equals x squared is. We know it's centered right here at the origin. Okay, I'm going to plot a few points that would be on the graph, just kind of real quick. Okay, so it's going to look something like this. But what is the transformed function going to look like? Or in other words, what is this plus 3 right here going to do to the graph of the basic function? How is it going to shift it? Well, because that plus 3 is inside the parentheses with the x, it's a horizontal transformation. Okay. And more specifically, it will shift it to the left. Okay, so we're going to say left 3 units. Okay, so I can get a different color here. Oh, this one is nice, this green. So I think about it like I'm just shifting this point to the left. So if I put it down here, and all those other points would shift to the left as well, it's going to end up looking something like this. Okay. You can verify this in your calculator as well, guys. We can also use Desmos, of course. So x squared, and then let's, well, we need to do all that. Let's delete this stuff. Let's type in here in parentheses x plus 3 and then square that. And look, it shifted it to the left. Okay. Now in your homework to graph these, or to graph these transformations, you first have to click on the quadratic tool. Okay. And I'll illustrate this here in a minute. I'll look at the homework, but what initially will happen is you'll have to click on the quadratic tool and it'll graph the basic quadratic function, so it'll look like this one in blue. And then it'll pop up a dialog box, and from that dialog box you'll dial in the transformations of your function. Okay, so if you need it to shift to the left 3 places, there's a dial in there for horizontal transformations. You just simply click on it and drag it to the left, and you'll see it moving that function. Okay. Like I said, we'll look at that here in a minute. Let's look at some of these other examples. Example 2. Describe how the graph of 1 over x minus 2 can be obtained from one of the basic graphs, and then graph the function. Okay. Well, first let me not use. I like that green though, that's really nice, calming. Let's see. Our basic function would just be y equals 1 over x. Our basic reciprocal function. Okay. And then our transformed function is y equals 1 over x, and then out beside it is the minus 2. All right, so the graph of 1 over x, I'm just going to roughly kind of sketch it in here. You remember, it has this shape. Remember, it has this shape because of that domain restriction, right? 0 is not in the domain of this function. So what will the transformed function look like? Or in other words, what is this minus 2 going to do to this graph? How's it going to shift it? Well, because the minus 2 is out here beside the function, it will be a vertical transformation, okay? And it more specifically will shift it down 2 units, okay? And so if I get my green, I'll just kind of shift this graph down 2 units, something like that. And then similarly over here, guys, I need to draw it going across the y-axis. Similarly over here, kind of come down and do like that, okay? So yeah. Now notice the basic function never actually crosses the x-axis. So when I shift it, when I shift the transformed function down, then it should never cross an imaginary line that's 2 units down. Okay, so you can see I've kind of shown that the way I drew it there. But let's do this one real quick in Desmos. So our basic function is 1 over x, okay? And then our transformed function is 1 over x, and then out beside it there is a minus 2. And look at that. Blue is the second, or the transformed function, and it is shifted down 2 units, isn't it? Okay. Alright, let's go to... Computer froze again. This is... Okay, and just like last time, I'm frozen again. Alright, well, we can continue though. Let's look at example 3. I'm looking at example 3 and I see a negative, and then I see in parentheses x minus 2, and then I see that it's cubed. Well, the fact that it's cubed, guys, means that our basic function is that basic cubic function. Okay? Y equals x cubed. And so our transformed function is negative. We could write g of x if we want, but I'm just using the y notation. X minus 2 and then cubed. Okay, so we've got a couple transformations in this one. We've got the negative, and we've also got the minus 2. Okay, well, we're starting on the inside, so what is that minus 2 going to do? Well, it will cause a horizontal transformation. And because it's a negative 2, it will shift it to the right 2 units. And then we'll take into account this negative number, and that will cause a reflection. A reflection about the x-axis. Okay. Or in other words, that turns it upside down, guys. So I'm just going to kind of roughly sketch in here the graph of, I remember some of the points of x cubed. Okay, from the, having graphed these from the table, using the table method. So I kind of know. So something like this. Okay. Well, what would happen if I take this graph of the basic cubic function and I shift it to the right 2 units and then I flip it upside down? Well, I can think about moving this point. So if I move this point to the right 2 units, it'll be centered right here, but then it's going to be upside down. So when I sketch it in, it's actually going to look something like this. I'm not drawing that too well. With the darker green. Yeah, it will look more like this. Okay, kind of cut across and then go down. Okay. So let's verify this again with Desmos. So our basic function is x cubed, and then our transformed function is negative, and then in parentheses x minus 2, and then we're going to cube it. And look at that. See that, guys? Our basic function is in red. Our transformed function is in blue. So it did shift to the right 2 places, and then it reflected about the x-axis. Alright. I think the next time I record another video, I need to know if I need to minimize the number of windows that I have open or what, but to keep me from, or to stop having these software issues, conflicts. Alright, well let's do a couple more. So example 4 here. The square root, this is, our basic function would be that basic square root function. Y equals the square root of x. Okay. And I want to show you in the calculator, find the calculator here. In the calculator, how you would graph the square root of x. So you go to y equals, let's delete that last function. Where do you get the square root operator? Well, it's right here, guys, above the x squared key, but it's in blue, so we have to hit second first. Then we put in an x, and then you can graph it, okay? And that's what the square root function looks like. Let me change my viewing window. There we go. Okay. So, what will the graph of our transformed function look like? Which is y equals the square root of x plus 1, and then there's a minus 4. Well, this one has 2 transformations. It's got this plus 1. This is like being inside the parentheses with the x, but it's under the radical. It's under the square root. So that's what we take into account first. That will yield a horizontal transformation. But it's not going to go to the right one. It's going to go to the left 1 unit. Okay? And then finally, we'll take into account the negative 4, and that is a vertical transformation, and it will shift it down 4 units. Okay? And so if I just kind of roughly sketch in, let's see, I remember some of these points for this function. This square root function, this is what the basic square root function would look like, square root of x. Okay? Well, if I take this shape, or all the points on it, and I shift it to the left 1, it would start right here, and then if I shift it down 4 units, it would actually start right here. Okay, and then it would have that same shape. So sketch this in. It would start right here and have that same shape, something like that. Okay. Why don't we check this one in the calculator instead of Desmos? Oh, well, no, let's use Desmos, because for Desmos, for the square root, guys, you actually have to type in SQRT, okay, for square root, and then it'll bring up that symbol. Then you put an X in there. So that's our basic square root function. So let me type in SQRT again, and I'll put, what did we have, an x plus 1 underneath the radical? Let's scroll to the right, and then we're going to say minus 4. And look at that. That center point and all the points on this shifted to the left 1 and then down 4. Okay, you guys see that? Alright. So, let's do one more from the notes, and then we'll take a gander at the homework. Example 5. Okay. Alright, well this one's got a lot of stuff going on with it, doesn't it? It's got a negative, and then in parentheses, x plus 2, all of that's squared, and then there's a minus 3 at the end. But the important thing in here is that it's squared, okay? And so that makes this a quadratic function. And so our basic quadratic function, let me write the word basic. The basic quadratic function, as you know, is just y equals x squared. And then our transformed function is negative, in parentheses, x plus 2 squared minus 3. Okay. All right, this one actually has 3 transformations going on. So we're going to start inside the parentheses. What's that plus 2 going to do? Well, it will cause a horizontal transformation, okay? And that will shift it to the left 2 units. Remember, it's the opposite of what you think. Okay. And then we're working our way out, and then we next encounter that negative there. So that will cause a reflection. A reflection about the x-axis. Some of my students like to remember it is by it flips, it vertically flips. Okay, and that's not a very good mathematical way of expressing it, but it works. And then finally, that negative 3 that's at the very end, that will cause a vertical transformation, and it will shift it down 3 units. Okay. All right, well, we know the basic graph of our quadratic function. Again, I'm just plotting a few points that I remember from the table. It would look something like this. Okay. But what if we take all of these points and we shift them to the left 2 units, and then we turn it upside down, and then we shift them all down 3 units. Well, guys, if we did that, the center point would go to the left 2, so it would be centered here. It would turn upside down, and then it would shift down 3. So that center point's actually going to end up right here, and then be turned upside down. Okay, so it will have this orientation, something like that. Okay. Why don't let's check this one in the calculator. We haven't really used the calculator much. Okay, so we'll type in here x squared. That'll be our basic function. And then I'll type in our transformed function. So negative, and then in parentheses, x plus 2. We'll close these parentheses, and we'll square that. And then we're going to say minus 4. Okay? No, minus 3 actually, sorry. And we'll graph both of these. There's the basic function, and there is the transformed quadratic function. Okay. All right. Well, the last thing that I want to do is just take a gander at the homework and mainly just show you how you're going to graph these. There may be a few that are multiple choice. Let's see here. Well, let's look at this one. So this says, this is our transformed function, the square root of x plus 11. Our basic function is just the square root of x. Now that plus 11 is going to shift it to the left 11 units. Okay, so just type those in, we'll check our answer. Then it's going to have us graph this function. Well, this one's multiple choice. So it's just going to be A. I was trying to find one though. Oh, well, this one's, yeah, let's do this. Hold on just a minute. look around here. Okay, why don't we start with this one? Okay, so it says describe how the given function can be obtained from one of the basic graphs. Well, this is a quadratic function. Okay, so you've got to select the choice, and you type in the basic function, which is just x squared. But this plus 5 is going to shift it to the left 5 units. So shift the graph 5 units to the right. No, shift the graph 5 units to the left. So it's going to be choice C. But we have to type in here the basic function, which is x to the second. Okay. Now once you've done that, you'll check your answer. Now it's going to have us graph it. So this is what I wanted to show you. So you're going to click right here to enlarge the graph. Now pay attention to the type of function it is. If it's a linear function, you'll click the line tool. It's an absolute value function, this one. But if it's a quadratic, you're going to click the x squared tool. And you're going to click anywhere in here. And what will happen is it, like I told you, it'll graph y equals x squared. Okay? But to actually transform it, you're going to use this dialog box right here. So if it needs to shift horizontally, you're going to shift it. See how it's moving? Okay. If it needs to shift vertically, you're going to shift it that way. And if it needs to be reflected about the x-axis, you're going to click on this option right here. Okay. And those three things are all you're going to have to worry about. Well, this one only has one transformation. It shifts to the left 5. So there, that's where I want it. And it shifted it to the left. I'm going to save this. It puts it in there. And you're going to check your answer. Okay. So when you're graphing these guys, you're not going to have to plot points. Whatever function it is that you're trying to graph, click that respective tool. Click anywhere in the coordinate system, and it'll plot the basic function for you. And then you'll dial in those transformations. Okay? Just the way that I showed you. Alright. Alright, well that does it for 7.2 with transformations. And so in the next section, 7.4, guys, I believe that's where we're going next. We are going to be studying quadratic functions in more detail. Okay? Alright, so I'll see you in that video.